Okay, our final look at kind of weird trig functions, not our usual sine, cos, and tan, is going to be looking at inverse trigonometric functions. So we've looked at the reciprocal functions, which is 1 divided by sine, 1 divided by cos, and 1 divided by tan. But now we're going to have a look at the inverse. It's very, very important that we don't get the inverse and the reciprocal mixed up. They are completely separate things. Inverse, which we write by using the word arc, so arcsin means the inverse of sine, arccos is the inverse of cos, and so forth. But we've encountered these before because it's the same thing as writing sine to the minus 1. We've all used that button on our calculators before. We all know what the inverse sine does, helps us find these angles. But we're going to write it a little bit more professionally using the word arc. Don't ask me why that's more professional, it just is. So arcsin x equals sine to the minus 1 of x. So pretty self-explanatory of what it is and how to use it. We've used it many times before. But we do need to work out how to draw the graph. The very first thing I want to draw our attention to is a typical sine graph. And I've just done between minus 180 and 180 for now. But what I want to draw your attention to is what this graph looks like. I've got the y-axis and the x-axis. The x-axis goes between 0 and, well, goes on forever. But in this case, between 0 and 180. The y-axis, of course, only goes as high as 1. So what is an inverse function? Well, I've got a video on it, but an inverse function is basically flipping the input and the output, which basically means flipping the x and the y in most cases, and in this case as well. So my x values are all our x values. My y values are all my sine of x. So how do we translate this onto the graph? Well, what I'm going to do is take each individual point on here and flip the x and the y values. So let's start off at the origin. My origin here, my x value is 0, my y value is 0. If I flip them, they're still both going to remain at 0. Now I want to do the peaks and the troughs. So at the peak here, I am at 90 degrees. And I'm going to stick to degrees, but radians are also a good idea to use. I might do it in both actually. So 90 degrees or pi by 2 radians. And my y value is 1. It's my peak. So on my arcsine, they're going to be flipped. My x value is going to be 1, and my y value is going to be pi by 2. So if my x value is 1, my y value is going to be, we'll do a cross, it's going to be pi by 2. So let's say pi by 2 is up here. Now the question is, what happens between these 2 points? Well, if I kind of look at this, my x-coordinate is increasing and my y-coordinate is also increasing. But if I have a look at the gradient, the best way that I can explain it is the gradient is curving towards x, if that makes sense. It's curving towards being an x equals 0 line. Right? Or a y equals 0 line, sorry, the x-axis. So if I invert that, it's instead going to start bending towards the y-axis. So instead of looking like this, it's going to look like this. And that's exactly what happens here. It looks almost like maybe a bit of a tan kind of thing going on. Now let's have a look at the negative. Well, once again, at minus 90 or minus pi by 2, I'm at minus 1. So that is going to switch. At minus 1 on this graph, I'm going to be at minus pi by 2 on the y-coordinate, which will be down here. Once again, this one kind of curves this way. So instead of that, it's going to curve the other way like that, and it is going to look like this. And this is my graph of y equals arcsine of x. This is it, okay? So the domain of my y equals arcsine graph is the range of my sine graph, which is between -1 and 1. X must be between -1 and 1. Yeah? My range, okay, it's not infinite. In fact, it only goes between -90 and 90, or pi by 2 and minus pi by 2. So my domain is -1 to 1, that's all my inputs. My outputs, I'm only allowed between minus pi by 2 and pi by 2. And that is what an arcsine graph looks like. Now, let's very quickly apply the same logic to cos. Okay, now let's take a look at cos. So over here, I've got my y equals cos x. I'm going to very quickly speed through this. The same logic as arcsine. By the way, arccos spelled with 2 C's. Don't know how you feel about that. I think it should only be 1. I know why it's 2 because it's arc and then cos, but just you know, look at that, much simpler. But alas, I'm not in charge. So very quickly, what's happening at x is 0? Well, at x is 0, y is 1. Flip those. At x is 1, y is 0. So I'm going to be at this point. And then here, at x is 90 or pi by 2, y is 0. Flip it. Y is pi by 2, x is 0. Connect those together. And I've got the first half of my graph. Okay, and then if I keep going, so I've got x is -90, y is 0. If I flip those, then x is 0 and y is -90. But if I do that, as I did with the sine graph, and maybe you'll notice something about what I did with the sine graph as well, I end up with x is 0, y is -90. And then I'm down here. And you might ask, okay, well, what's the problem with that? I can just, connect those and we're good to go. But I can't do that. The reason is, and the reason my sine graph stopped here and didn't keep going upwards or keep going downwards is because I need to restrict it to being a 1-to-1 function. Now, if you remember from your functions course, I think I mentioned this in one of my videos, or I might have kind of skipped over it a little bit. But in order to invert a function, it can only be 1-to-1. A sine graph and a cos graph, both look like this, are both 1-to-1. 1x value for 1y, 1x value for 1y, 1x value for 1y. But here, already, I've got 1x value to 2 y values. And that's not allowed. That can't be allowed. So I need to restrict it. I need to restrict it even further. I need to say, okay, I'm not worried about this. In fact, I'm going to take this point here. You'll see why in a second. At -1 and at -180. And if I plot this, well, x is -180 or minus pi, y is -1. Flip those. X is -1, y is pi. And I end up with my cos graph looking like this. And this is the restricted version, it's the final version of my arccos graph. If I kept going this way or this way, then I will end up with a function that is not 1-to-1. Also, sorry if there's loads of jumpy edits. I got the plague, so I keep coughing and no one wants to hear that. Right, let's have a final quick look at the tan version. Okay, for the arctan graph, I could go through and do the same process I just did with cos and sine, mapping each point and finding what's its x, what's its y, flipping them and plotting it. But I want to use this as an opportunity to bring your attention to something else, which is something that was discussed in earlier functions videos and also just in earlier courses you may have done on functions in general, which is that if we inverse a function, so arctan, the inverse of tan, it is the same as mirroring it, flipping it in a y equals x line. And we can apply this to sine, cos, or tan, or any function at all. What I mean by that is if I want to draw an arctan graph, instead of doing all those points, I can do this with sine and cos as well, I want to sketch on a little y equals x graph, and imagine I had a mirror there. Imagine I had a mirror there, and flip each of these points. So that point might look something like that. This point here, 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 and it's looking something like that. That's mirrored in that line. And then down here, the same thing. Draw something that is mirrored in my y equals x line. And this is what my tan of x, or arctan of x function looks like. You might wonder why I didn't show you how to do this before with sine and cos, because it's a bit easier, but it's still important to know where the values come from, especially with domain and range. So, what is the domain and range of arctan? Well, as you can probably notice, or maybe you haven't, there are asymptotes on the y-axis. Why? Because in a standard tan graph, there are asymptotes on the x-axis. Where are those asymptotes? Pi by 2 and minus pi by 2, or 90 and minus 90. So where are these asymptotes? Well, they are at pi by 2 or 90 and minus pi by 2 or minus 90. What about the domain? Well, unlike the other two, my arctan graph doesn't have to worry about any one-to-one nonsense. It just goes on forever along its merry way, just never interacting with this minus pi by 2 line. It just follows that asymptote forever. So my domain is everything. It's infinite. There are no restrictions on my x coordinate. My y coordinate is between these two, never touching these two, but my x value can go on forever.